Hi, so I'm going to go over 13.4c, and so kind of looking at this problem, this part, it's pretty long, but it's not too difficult. It's just the algebra is a little tricky, so kind of going over the inverting the motion of the Eulerian description. This is to end up getting acceleration. So in the previous part, these are the velocities we ended up getting. So you have v1, v2, v3. And so kind of continuing with that right here, I'm going to focus on v1 and v2. To get the acceleration of 1, we're really just going to take the derivative, very similar to how we've done it in the past. And putting that into a derivative calculator, that spits out this derivative right here. Very similarly, we're a sub 2, take the derivative, and it ends up getting this acceleration right here. And then a sub 3 is actually going to be 0, and I totally forgot to write that down. But yeah. And so this is where it actually kind of gets a little tricky, just by the amount of things you have to keep track of. And so for the material derivatives, we need to use this equation that takes into account our fixed and non-fixed reference point. And so right here, we're going to take in terms of dt, and you have to multiply this and takes it in terms of dx. And so how I wrote it out here is like that. So a1 is going to be this derivative here, or derivative of this first velocity that we had plus this v1 right there with the derivative in terms of x2 or x1 and then x2. And so putting these in here, and I just simplified this equation and ended up getting what we had in the last one, which they should line up. And so very similarly, I took the dv2 of dt plus v2 d sub vt over x1 plus v2 of x2. And so again, that's where our derivative came from, of right here, and our v, and then with our derivative in respect to x1 and x2. So yeah, and then lastly, like our acceleration of 3 is 0.